Something is happening at the North Pole, in the Arctic region. It's happening quickly. It is monumental. And at least as much is underway all the way down south in Antarctica. The sea, ice, winds, ocean currents. You surely know about climate changes. And they are the strongest here. When the rest of the world gets a degree warmer, one can expect much greater changes in these areas. But what happens at the poles doesn't stay around the poles. Changes in the weather here will affect the entire planet. Which brings us now to meet with the scientists who are laboring to understand just what is happening. In Stockholm, for example, researchers are running down an extreme packing list as they prepare to spend weeks aboard the icebreaker Uden on an expedition to the North Pole. Even though humans have sent space probes throughout our solar system, there are large areas that are still unknown here on Earth. Most of what is unknown here is found around the poles. One of the project leaders on the expedition is Michael Tjärnström.
This is not something you come up with within a year. This is something you plan over several years. So in the beginning, it's a lot of brainstorming, a lot of enthusiasm, things that we think we're going to be able to do. And the last couple of months before the expedition, you lie awake at night and try not to think about everything that can go wrong.
But all of the measuring equipment and all of the measurements are necessary. The Earth's atmosphere acts as insulation around our planet. And with all of the greenhouse gases like carbon dioxide we've released, the world now is getting warmer. Energy from the sun warms the planet, but radiation that the planet would normally give off is increasingly trapped. And weather in here moves in great columns from the outermost atmosphere to the bottom of the ocean. All of these pillars are connected to one another, affecting each other in what we call the climate system. And this whole climate system is what scientists must understand in order to determine just what is going on with our planet.
Ultimately, the climate system is driven by the temperature difference between the tropics and the poles. And you cannot really claim to understand the climate system as such if you don't understand all the aspects of the different parts of the climate system. And the Arctic is an integral, important part of that system.
But when one wants to study weather in the Arctic, they needn't necessarily travel all the way to the ice closest to the poles. The Arctic region actually begins here in Sweden. On a lake in Abisko, one of the thousands of measurements is being prepared. Observation must be taken from as many locations as possible in order to understand the climate system. Here, they measure wind and temperature at different altitudes. These measurements are important to understand what is happening to the ice, to understand how it is warming. Because whether the ice remains or melts is very important for the entire weather system.
This is one column throughout the atmosphere. the ice, and here is the ocean.
Where there is ice, it acts as a large mirror which reflects parts of the sun's heat back into space again. But if this reflective ice layer disappears, the sun will begin to warm the sea, which can affect the whole Earth.
So because the system really changes when you go from a system with sea ice to a system without sea ice, it's really important to understand what's happening, when it's happening, and how fast it's happening.
For the extremely high altitudes, researchers use weather balloons that can reach up to 40,000 meters. That's over 131,000 feet, 4 times higher than where airplanes fly. Warmer air masses, warming ice, and warmer water will come to affect every plant, every animal, every organism which comes into contact with the new, hotter weather. The researchers in Abisko and soon on the icebreaker Uden use their measurements to build so-called climate models to try to predict how things will be in the future. But sometimes it's also possible to create a bit of the future today. Researchers in Umeå have constructed these small lakes where life is already like it will be in times to come elsewhere.
So here we study climate impact on lake ecosystems, and especially temperature and runoff from land to lakes and ponds.
Jan Carlson and his team want to see how fish are going to feel tomorrow in the millions of lakes up north.
So here we have ponds that we warm 3 degrees. That is what is expected in the future with climate warming in the coming 50 to 100 years. And over here we have natural conditions. That is the normal conditions that we have.
But the lakes aren't only going to be warmer. Because in the future, as it rains more and as more of the land thaws, more of the old plant matter will be washed down into the lakes. The lakes will then become darker, browner. This threatens the plant life in the lakes and thus the fish's access to food. How fish adapt can therefore be a warning sign that the large bodies of water aren't well either.
The fish is a key organism that integrates what is happening in the ecosystem, and it's also an indicator of the health of the system. If the fish is bad, the ecosystem is not functioning properly.
Results are already coming in from the artificial lakes here, and it's not looking so good for the fish. In warmer water, the fish are expending more energy. They then have to eat more. But in the heavily tanned lakes of the future, there will be at the same time less food.
It feels deeply concerning. It's concerning for the future of these lake ecosystems. But on the other hand, it feels great to have this new knowledge and deep understanding of these systems that most likely can give us tools to manage these systems in the future.
From the warmer lakes in the north, we now scale up to the coldest and most immense waters we have. Water which is absolutely crucial for the question of the Earth's heating. What we are talking about here are the seas around and underneath the ice at the South Pole. This cold water here cools the Earth. This is like ice in a glass that helps keep the Earth comfortably cool. But what is happening now with this system? To take these measurements that can predict the future in the Earth's most inhospitable place, research is underway far away on the west coast of Sweden. Sebastian Swart is leading a large project to teach robots to survive for months in the Antarctic waters and to dive under the Antarctic ice. The technological challenge is enormous.
So going under the ice with robots is so difficult and hasn't been done before because really we can't communicate with the robots under ice. We have to program and change how these robots behave so that they can look after themselves when they go under the ice, collect data, but then still come out from under the ice to send us the data and the information and survive.
These are pictures from a previous trip Sebastian made to Antarctica. It is difficult enough just launching the robots. But getting out of the inflatable boats, which is needed to retrieve the robots, is literally life-threatening. But this mission is important, since the ocean currents in the 4,000-meter deep seas in Antarctica, in principle, affect the entire ocean. And it's not only the cold here that is important. The water here also swallows up extremely large amounts of carbon dioxide.
So the Southern Ocean is a really important place, especially for carbon dioxide, because actually at the end of the day, about a quarter of all the carbon dioxide that a Swede or anyone else produces ends up actually being absorbed and going into the Southern Ocean, into the ocean interior.
But to understand how much Antarctica can help keep the Earth tolerably cool, and to understand how fast the ice here will melt, exact measurements are needed. And there aren't any, yet.
One of the big problems that we've had is that we have no observations of what's going on in the ocean or the climate around Antarctica. There's actually been very few observations. They've had to rely on a few ships that have gone down from South Africa, Australia, New Zealand, wherever it may be, to collect those observations. So they're very rare, and they also don't occur in many times of the seasons, like in winter or autumn or spring, which are fundamental to how the climate system works. So in fact, by sending down these robots and having them there for very long periods of time and over seasons when we don't want to be there with a ship, we can get new information and therefore understand the system as a whole and how it works and how it may impact our climate and eventually how it may impact humans living much further away than this remote area like Antarctica or the Southern Ocean.
Ja, men nu har de tänkt klart här så vi kommer att sjösätta här så vi ligger något längre upp i låret.
And now everything is ready for the launch at today's robot test on the West Coast.
Yeah, no, it went really great today. We're very happy with how it was launched, and the team did a super job. And so we haven't damaged the vehicle or anything like that, which is great. And next it's Antarctica. We'll be ready.
Michael Stjernström, whom we met earlier when his team was packing for the large expedition to the North Pole, is now back. Here are some of his own pictures from the trip. And things went well for the most part. After the long journey on a course for absolute north, the researchers finally reached an ice flow stable enough to dock to.
Så här såg det här islaket som vi var på. Det såg ut så här när vi kom dit den 12 augusti, tror jag det var.
Here, they are just a few kilometers from the geographical North Pole. They are at the top of the world.
Här kan vi nog sätta en mast, säger han, tror jag.
And on the ice around the icebreaker, they erected measuring stations to observe and experiment during the weeks they would be there. At first, the weather was good. The only thing that disturbed them were the bears.
Och det är klart att det här ställer ju till med saker, va? Därför att om man arbetar på isen då så...
Safe at home in his office in Stockholm, Michael remembers.
So here it's chewing away on an oceanographic buoy that actually had to be fixed afterward because it ripped the cable on the buoy. And then it went on to play with these red flags. And it seems like moving stuff and color, red colors are things that attract them.
At the end of the journey, there was a huge storm that sent a lot of the researchers' equipment to the bottom of the ocean.
Kanske 2 miljoner eller så värde av instrument ligger på havets botten.
But before that happened, they managed to do what they were there for.
Kan du släppa?
To release the balloons like in Abisko in the Swedish mountains, with the most advanced instruments measuring, among other things, how much the sun is heating the Arctic ice cap. The data from all these measurements will take a long time to analyze, but eventually it will add to our understanding of the climate at the poles and thus our understanding of the climate around the whole Earth. This Michael Stjernström is sure of.
And I mean, we have learned a lot during the last couple of decades, and we can see now today how this increased understanding have moved into our models, and the models are becoming better. So we're in a better place today than we were 20 years ago, but we can still improve things very much, and I think it's really important that we continue doing so.
The world is warming. The ice around the poles is melting. It's all about heat and cold, movements in water and air so large that it is almost impossible to comprehend. In small steps, measurement after measurement, there are scientists tirelessly reading the weather. Because if they manage to build the enormous models that are needed, we can understand what is about to happen.